Thanks, guys. Thanks for tuning in again. And I'm sincerely sorry for the technical glitch. So today I'm just gonna cover the related work, the research questions and gaps, then the methodology and how to approach it, wrapping up with the experimental design regarding that methodology. To use eye tracking for empathy evaluation and to go this project, it requires a mix, an interdisciplinary study of a wide range of complex dimensions, as in museums, eye tracking, empathy, and human-computer interaction. We all know that museums' role changed from protecting and preserving objects into advocating ideas, so that digital technologies are used to communicate those ideas with visitors. However, how can we make sure that those technologies are successful and effective? With the museum role, the critical role in society provides the public exhibitions and educational programs. Previously and in the past, museums focused on displaying expensive and rare items. However, nowadays the focus of museums has shifted to educating communities through spreading awareness regarding social, cultural, and economic conflicts as gender gap and racial prejudice. This change in notion from displaying objects towards education and awareness means that there is an increased need for interaction and audience engagement. With the technology as a tool provides the opportunity to improve interaction in museums where there is an increasing amount of research in this area. While discussing museums, we notice the development of its role and definition. Some argue that museums basically are made to only protect, preserve objects, while others, researchers, believe that museums have a significant role in the society. The role of museums changed from one of exclusivity and differentiation between the elite and the people to one of inclusivity and open-mindedness. Speaking about new mythology, it supported the position of language and education to shift from the whole focus into more for the ideas and the creativity. The new museology created a debate about the social roles of museums and encouraged new communicative and new communication styles, which helped museums become a platform for conversations. However, these communication styles require enhanced engagement and interaction processes to improve the communication style from the distant observant into more interactive engagement. To target the low visitor engagement and accessibility issues regarding remote museums and the newly COVID safe regulations and restrictions. Experts suggested human computer interaction to target some of these limitations, but what's human computer interaction? It's the communication process between a human user and a computation based system. The interactive layer between the human and the computation side is known as the user interface. The usability of the whole human computer interaction as a system and a process is dictated by the effective and efficient use of the UI, the user interface. With these mods, the user interface mods changed and developed throughout time, starting from a command line, which is simply a keyboard, into graphical mods such as the screens, into more natural input and output systems as the eye tracking, the hand gestures, and the touch screens. These developments of the user interface led into the development of human-computer interaction from the two-dimensional, as we said, the desktops into more advanced three-dimensional techniques as the augmented reality, virtual reality, and mixed reality, with a uh, higher impact on the levels of empathy resulted by the higher immersion technology. The virtual reality have different styles as the 3D modeled environments in the top right corner, and of course the 360 videos in the far right bottom corner. Brain activity studies stated that little research have been done investigating the low and high realism experiments. It aims to reduce the cognition load while maintaining the high and the overall immersive VR performance. The cognitive load affects the immersive VR performance, and it can be resolved through experimenting the lower realism environments, where the 360 videos and the 3D models discussed earlier have different levels of realism, ranging between the cartoon style ones into the hyper realistic versions. From the chart, we can notice that the empathic response and the realism have a gray area, which shows the non-linearity relationship between the empathy and realism. Uh, Empathy. What's empathy? Empathy is the ability to understand and feel the other's perspective. The main factors used to investigate empathy are empathic concern, perspective taking, fantasy, and personal distress, usually due to short experimentation period and the use of non-immersive experiences. The fantasy and the personal distress are disregarded, while the emotional concern is known as the emotional empathy, and the perspective taking is the cognitive empathy, which is the ability to understand the other's point of view. This study focuses on the perspective-taking subscales of empathy due to its impact on the human perception and behavioral changes. But why empathy in virtual reality? Virtual reality is well known as the empathy machine. It is used to develop and elicit empathy. With empathy development is the introduction of a set of feelings or perceptions regarding an individual, group, or phenomenon. This figure shows the whole process of inducing empathy regarding a subject as viewed by the designer and then reflected to the reviewer. Researchers used this process in order to spread awareness regarding topics as colorblindness, homelessness, and imprisonment. In addition to those examples, empathy in VR has been well researched by different disciplines, including education, psychology, environmental studies, and business. It's a fairly new research area, with most published during the past 5 years. Most empathy studies were done in non-immersive virtual environments. This highlights the need for more deeper knowledge into the comparison of the empathic response resulted by the different immersive virtual environments. After discussing empathy development, and the question is how to measure that empathy in virtual reality. There's usually three main categories, which is the retrospective self-reporting, as surveys, questionnaires, and interviews. Its downside is the subjectivity, and it relies on the memory to reflect and answer the surveys. The momentary self-reporting, as think alouds and present sliders, it may cause distractions and lead to immersion and empathy variations. Lastly, the physiological tracking systems, which constitutes of dynamic measuring tools such as heart rate, brain activity, and eye tracking. Self-reporting questionnaires are widely used by researchers, followed by the physiological measures. This study recommends the advantages provided by the live tracking and recommends eye tracking that is integrated, the head-mounted devices used for virtual experiences. Eye tracking offers a solution for the iterative issues of calibration and the obstructiveness of brain activity and skin conductance measures. Eye tracking measures are eye movements and changes in the eye biometrics. Eye movements have been extensively investigated to understand human behavior and cognition. Researchers extensively claim that eye tracking could replace self-reporting measures as surveys and questionnaires, while eye tracking is applied in different fields due to the advances in microcamera technology, which provide an advantage for researchers, of course. And some of these applications are psychology, economy, education, and training. Eye tracking has been used to understand the effect of immersion and interaction provided by the three-dimensional VR experiences on users' behavior, learning, and empathy. Some of the spatial and temporal measures are gaze origin and direction, pupil size and position, saccade rate, saccade duration, and scan path. The most valuable measure here is the pupil diameter or pupil size, which is affected by the lighting, multitask, cognition load, and empathic response. The study focused on the pupil dilation, and the pupil variation resulted by the empathic response, where tolerances and bias measures are deducted through averaging the diameter during baseline measurements and then experience measurements. As we discussed, museums are showing a need for enhanced visitor-object communication method to meet users' needs. To achieve that, a variety of fields as a human-computer interaction, empathy, and eye tracking contribute to the proposed solution. Although museums are involved in developing the digital engagement to tackle the low engagement experiences, they lack an evaluation system for the user's empathic reaction and engagement. The evaluation of empathy usually relies on self-reporting measures, which is subjective. Therefore, comparing the eye tracking metrics provided will provide us with an insight into the visual interactive modality. Finally, literature highlighted the need for investigating immersive VR experiences and its impact on empathy. Uh, some of the focus of the study will be, of course, one, the effect of realism on empathy and the difference between the delivery media and 360 videos and the 3D models, while there are questions related to the evaluation method and if the empathy can be objectively evaluated through eye tracking in virtual reality museum experiences. How we'll be doing that? Through, of course, mixed method approach and, of course, a mix of qualitative and quantitative tools to do that. The case study will be the primary research method. It addresses a phenomenon related to Geelong's manufacturing industry and its perception among the local community. The study is a mixed method case study and utilizes the explanatory and instrumental case study. It implements a scene from a manufacturing factory or plant in Geelong. And then, of course, the use of the different data, the different collection tools, it increases the internal validity of the case study. And later on, the data would be interpreted through correlations, regressions, multivariate analysis of variance, and different statistical tools. The case study documentation constitutes the chapters of a conventional dissertation, audio and video recording of the VR experiments, and publications too, in order to help that generalization and application of the study. This project is the component of an overarching larger research study investigating the social value of engineering and design heritage in post-industrial cities and its digital interpretation in a museum context, initiated by Deakin researchers. Geelong in regional Victoria is a post-industrial city with a long engineering tradition and one of the largest manufacturing hubs in Australia. Deakin researchers reported interesting numbers and quotes that resulted from an online community survey with 91 participants between 2019 and 2020. The survey results showed 25.6% of the participants agreed that Geelong should celebrate its design and manufacturing past and traditions to motivate the younger generations to become engineers or designers. However, 32.9% agreed that non-locals see Geelong in a negative light because of its industrial past. In the interviews reported by Deakin researchers, an engineer was asked about the community's perception regarding the engineering and manufacturing. The answer was dangerous, noisy, and boring. The engineer concluded that the industry didn't focus enough on promoting the positive side and capability of advanced technology available in Geelong today. Therefore, this study focused on the perception and awareness regarding the local manufacturing sector in Geelong. And as said in the introduction, museums advocate for the diversity and inclusion causes, but we want to evaluate the impact resulted by VR on these perceptions. The qualitative tools are used to help participants reflect on their perceptions and emotions with a mix of qualitative tools as participant observations and the semi-structured interviews, which helped us design the content of the experiment and meet the exploratory side of the case study. The quantitative measures aim to investigate the correlations between the physiological measures and the physiological side and the empathic subscale. Some of them are surveys, correlation studies, multivariate analysis of variance, and the eye tracking experiment, which is a highly controlled environment, can be applied, of course, in the laboratory through integrated eye tracker and the HTC Vive headset, shown in this figure here with the general coordination system of the headset. The virtual environments have two styles, 360 videos and 3D models. Each and every style has different scenarios. Each has the realistic and the cartoon style effect with a minimum of 40 participants for each and every, of course, as a total for the whole experiment, with 10 randomly allocated for each and every scenario. The main tasks are the introduction, familiarization, training, engagement, and evaluation. There's 5 main parts of each and every experiment, which is the pre-intervention questionnaires, the first scenario, followed by a break, second scenario, and then, of course, the final debrief. The total duration should be ranging between 39 and 43 minutes. This study uses immersive virtual experiences, as we said, and it's the HTC Vive Pro I series head-mounted device. The VR system is a binocular headset, which means it presents the video on the screen ahead of both eyes. The present refresh rate, field of view, and 5 to 8 minutes per scenario as experiment duration will lower the risk of simulated sickness. Well, the eye tracking system integrated with the headset has a gaze data output of 120 Hz and an accuracy, a really competitive accuracy, 0.5 and 1.1 degrees compared to the commercial available headsets. The Unity 3D as a game engine is compatible with the interface required to present the eye tracker output, which are timestamp, gaze origin and direction, pupil size, pupil position, and eye openness. As we discussed, the project will focus on the pupil size variations and the main dependent variable to be correlated with the empathic response. Thanks for tuning in today. I hope you guys enjoyed my presentation, and I'm looking forward to answering questions. Cheers.